Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for any of our speakers, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions, and we'll try to get to as many as we can near the end of today's webinar. Also happening at the end of today's webinar is a drawing for 6 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 6 lucky winners. All right, with that, we'll go ahead and kick off today's webinar, which is Securing Red Hat OpenShift Containerized Applications at Enterprise Scale. Our speakers today are Vijay Arungurakai, I think I got it, hopefully, who is Senior Solutions Architect, ISV Embedded Partners at Red Hat, and Jody Hunt, who is Strategic Solutions Engineer at CyberArk. Welcome, gentlemen. Thanks so much for joining me today. Vijay, I know you are going to be getting us started, and I know you got a great presentation on tap, so I'm going to put myself on mute and let you get right to it.
Thank you, Charlene. Hello, everybody. Good afternoon, good morning, wherever you are. Thank you for taking the time to be with us on this Red Hat CyberArk webinar. I hope this is the first of many that we have today. I'm going to be running through the first half of the presentation, and I'll pass it on to my good friend Jody to walk us through the next half. And then he also has a demo, which will help us understand how CyberArk's product and OpenShift work very well together. So without further ado, let's jump straight in. So I'm going to do a little bit of a history lesson because I love history, and providing context to our conversation actually helps all of us understand what happened in the past and how it led to where we are and how it's driving us into the future. So Red Hat currently is the world's #1 provider of commercial IT products and solutions based on open source software. The key term here is open source, right? So we are a firm believer in working with the open source community, fostering what they do today, looking at our customers from an industry perspective, where they want to go, what could come down the lane 5 years from now, 10 years from now, and how we can make that a reality by working with the open source community and then building that or bringing that back to make it enterprise grade products. We are fortunate that we work with more than 90% of the Fortune 500 companies. They at least use one or more of Red Hat's products and solutions in their data centers or on the public cloud environments, wherever they are currently present. We have definitely more than 14, 15,000 employees currently, and they're spread across the planet today in more than 105 offices across 40 countries. What that actually means is we want to be close to where our customers are. Instead of our customers being pulled into where we are, we want to be working with them day in, day out. And also, we are also the first $3 billion open source company in the world, and we are incredibly proud of that particular achievement. So this slide presents how Red Hat works with the open source community. Every single product that we have came from the contributions of both the open source community and the Red Hat developers who have worked with those communities. To begin with, Fedora and Red Hat Enterprise Linux came from that. We took that source code, hardened it for the enterprise, and made it available to our customers and partners. And that same mantra has been applied to every product that we have, including virtualization, OpenStack, OpenShift container platform, CloudForms, Ansible, anything that you can take off, that's exactly how we roll. And anything that we acquire also gets to the open source community, and then we bring the goodness of what we had, put it out there for everybody's opinion and then be able to take the goodness from it and take it to our customers and partners. And that has not changed over the last 2 to 3 decades. It stays the same, and it will stay the same going forward. To begin with, when like say for instance, a decade ago, when folks said Red Hat, and even I was a party to it, the first thing that comes to anybody's mind is, they're a Linux-based company. Sure, it still is, but we are a lot more than that. So as you can see, this kind of provides you a snapshot of the gamut of products we have across the spectrum, from the infrastructure level to a platform level to middleware and integration and even services, right? And we are huge on those. So we have products to cover every aspect of a customer's or a partner's development ethos, and we work to build developer tools. We work to build automation and management tools, so that at the end of the day, when a customer or partner uses our products, they trust us in what we have done, and they see the value by using our products and do what they can do best and be successful in that business. And this is a great slide which kind of goes to show like how rapidly we are developing certain products like OpenShift and the others, but also what we have from a broad spectrum perspective. Switching back to OpenShift, which is the theme of this particular webinar, OpenShift 4.4 is the latest release that we have, which is being GA'd at the end of April. OpenShift 4.5 is slated for release in a month and a half from now. OpenShift 4 itself kind of is a paradigm shift from where OpenShift 3 was. A lot of things changed underneath, and one of the biggest changes that was made was how to make it easier for customers and partners to install the product itself. So with OpenShift 4.4, we have brought Red Hat's virtualization as an installer provisioned infrastructure, so it makes it pretty easy to get it up and running if you already are using Red Hat's virtualization in your data center. And also Azure and OpenStack, we have brought it on par with the latest release of OpenShift. We've also gotten closer to the upstream Kubernetes version, 1.18 being the current one. We're at 1.17 with 4.4. And there's a host of other features that have already been GA'd, like the serverless part and service mesh, Helm 3 support, and a host of other developer features. And OpenShift also doesn't stand in isolation, just like any of our other Red Hat's products are. Storage is a key part of it, and we do have products like OpenShift Container Storage, which is on the same release cadence as OpenShift Container Platform itself. We've created a number of features around it and made it easier to integrate both the storage aspect and the OpenShift Container Platform itself. To give you a broader view of what OpenShift can do, it gives you the same experience across physical, virtual, or the public cloud environments, wherever you want to run it. It is built on top of Red Hat's Enterprise Linux and RHEL Core OS. Again, it has Kubernetes under the hood. That is the orchestration mechanism we have, but it adds a lot more services on top of the vanilla Kubernetes that you'll find out there today. With respect to platform services, with respect to application services, and not being prescriptive of forcing a development team to move to being cloud native and then being able to deploy their applications on top of OpenShift, you can bring your legacy applications with few tweaks, as long as it can be containerized, can run on that platform and take all the goodness of the platform and then be able to be successful at it. And that's why I said that we're not prescriptive about it. You can take any route to wherever you want, however you want to do it, but OpenShift is there to be able to help you get to where you want to go. And also there's a host of other developer services, and it's constantly evolving, so that we work with the developer communities out there. We see what the requirements are, what the need is, and we always try to address that gap, fill that gap with tools and of course tooling to be able to kind of ease the burden on their lives, to be able to bring newer features to their market from their application perspective. And at the top is the multi-cluster management. That's a newer product that we have come out with, which helps you manage multiple clusters across on-prem or public cloud infrastructure. So it kind of gives you a single pane of glass view for all of the OpenShift deployments that you could have today and into the future. Going back to that consistent platform theme, the subscriptions for the platform, the OpenShift Container Platform, is the same across on-prem and public clouds or even private cloud. It gives you the same level of capability to do that installation. Once you do either an installer provision infrastructure or an user provision infrastructure, most of it is automated today. Of course, there are a few differences between them, but you get the same platform, the same product, the same feel. Multi-tenancy is by default. It's secure by default because it runs on top of RHEL and RHEL Core OS. over the updates are available. You can monitor and also do chargeback based on how you slice and dice the namespaces across your organization. And it's a pluggable architecture, meaning we closely work with our partners, say for instance, the way they build their operators or their Helm charts to be able to deploy their products onto the platform successfully by reducing the effort that the end customers have to do to be able to use any of our partners' products. And OpenShift is very, very big on developer productivity. So self-service provisioning, meaning like if a developer wants to test something, he can, as long as there are privileges provided, he can go in and request for a namespace or a project within OpenShift, pull the code from SVM, build it, test it, and throw that environment away. So that level of self-service provisioning is available with OpenShift. Again, you can do CI/CD pipelines, you can run Jenkins outside, or you can run multiple Jenkins slaves to do all of your build jobs, CI/CD jobs, to be able to move the developer workloads across environments from dev to production, configuration management with respect to config maps, and there are a host of other partner products that are available to be able to help with that. And one of that is going to be key with respect to security, and that's what Jody's going to talk about. And also app login and metrics, and how you'd want to leverage that information to be able to do analysis and analytics, both from an infrastructure level and an application performance level. Those capabilities do exist. Everybody can run either Spring apps, Spring Boot applications, Java-based applications, Node.js apps, Python apps, microservices, and all of the languages that are available today, including relational and NoSQL databases. Everything can be run on the OpenShift container platform. And that's the range of services that it provides and capability it provides for you to run any of the workloads, including, say, for instance, .NET Core workloads. So these are the supported providers from an IPI and a UPI perspective. Like IPI provides 100% automated installation, and that's available on all the public clouds. And say, for instance, if you're doing an on-prem private cloud with OpenStack platform, and if you already have a tie-up with AWS or Azure or Google, and you have infrastructure, you can still leverage that and to be able to install OpenShift on top of it. So there's two different types of offering. We call that OpenShift Dedicated or Customer Managed. And OpenShift Dedicated today is available on AWS, Azure, and Google and IBM Cloud, where you simply come and request for, hey, I need to have a cluster with so-and-so things. So Red Hat and, say, for instance, AWS or Azure or Google, we help get that installed for you, and it's available for you from day one to be able to deploy applications and do what you do best. Or you can either do custom managed if you say, for instance, already have a tie-up with those partners, and then be able to do install OpenShift and deploy applications at a later stage. Again, ARO is something that we have, where we work very closely with Microsoft, and like Microsoft and Red Hat work together so that you don't experience or need to experience the installation part or the management part. Microsoft and Red Hat takes care of that, and those similar things are available across AWS and Google and IBM Cloud as well. This is another slide I'm very proud to talk about, because I see a lot of customers adopting OpenShift, and this has steadily increased over the past 5 years across OpenShift 3 to OpenShift 4. And you can see that a lot of these customers are in various industries and verticals, including banking and financial services, healthcare, airline industries, aeronautics. They're all there, and including travel and hospitality. There are a lot of customers who see the greatness of OpenShift, what it can do for them, how it can leverage their developer teams' capabilities to be able to bring features and products faster to market. That's why you steadily see an increase of OpenShift customers being able to adopt this product. And then it's not just like these are newer customers. Whoever we have had in the past, they're still with us today, and they love the product for what it is and how the future is actually shaping up for this product to be. And this would not have been possible without our partners, because they form a large part of our ecosystem, because they build their solutions on top of Red Hat's products, and that is another huge factor, success factor for us in this whole grand scheme of things. back to the same point about what workloads can be run on OpenShift. You could run all the databases, including relational and NoSQL databases. The new big hype about AI and ML workloads, we are working with all of our partners and the community out there to be able to bring those to OpenShift. There are some customers who are already doing that today. DevOps, absolutely, you can do that. Security, and Jody's going to touch upon that. It's a huge thing because it doesn't matter if we're able to build a platform and put it out there, but if it's not secure, we will not have any customers on it. And security is a very, very key aspect of not just building the platform, but how we manage it and maintain it going forward. Monitoring capabilities are already baked into the product. You can either use those or you can siphon the data, and then if you have any external tools, you'll be able to use that as well. Big data workloads also run, and when we have partners who have brought in their product to be able to build their own private platform or private cloud on top of OpenShift itself. So that's the greatness and the goodness of the product, which helps you do whatever you need to do as long as you meet certain criteria to be able to do that. Operators is a key theme. That's one of the ways that OpenShift helps. Say, for instance, we want to build a product which has certain capabilities and you want to kind of lessen the impact of installation and maintainability, you would want to build an operator, package your product as part of it, and then be able to deliver it as part of the operator hub or even the Red Hat marketplace that's out there today. So it is one of the key things that we attribute to, and that's something that everybody is looking at, and we advocate that on a day in, day out basis to be able to build a product and tie it to the operator framework. An operator SDK is just like your Java SDK or anything out there, which kind of gives you a platform to build an operator on top of it. With that being said, and without further ado, I would like to pass the buck to Jody. Jody?
Hey, Vijay. You guys hear me all right?
Yes.
Awesome. Thanks for that intro. So as Vijay said, security is top of mind with OpenShift. Anybody that's worked with OpenShift or moved to OpenShift from Kubernetes will see that firsthand, that there's a lot more role-based access control. I always describe it as the hardened version of Kubernetes. So when you're serious about security and Kubernetes, it's going to be OpenShift that you're going to be using. We see a ton of interest in OpenShift in our install base, simply for that reason, because when people are security minded, they tend to be using our products. And when they're moving to a container orchestration platform, they're going to look for the more secure platform. So the healthcare customers, the financial services customers that we talk to, the customers that are really security minded tend to be using OpenShift over Kubernetes. Let's see, can you advance the slide there, Vijay? So the thing that we are very cognizant of is that sometimes the relationship between security and development can get a little tense. And so we want to mitigate that as much as possible. These are two very important organizations in every company, and both have their agendas, the things that they want to do. Development wants to deliver business value. Security needs to make sure that the business's assets are looked after and protected. And sometimes those goals are in conflict. So as much as possible, what we want to do is enable the development organization to be secure without overly impeding their ability to deliver business value. So this is top of mind, and when we're delivering solutions, is how do we make things easier for the developer in such a way that security just happens, that it's a part of their workflow and not something that they have to be constantly aware of and have to work through. If you make the right thing to do, the easy thing to do, then compliance comes naturally. And so that's really what we want to do, is provide that kind of capability. Vijay, can we go to the next slide? So this is describing that. What we're enabling the developer and DevOps organization to do is consume secrets. And that's what we're going to walk through, is various ways that applications can consume secrets to connect to a target system, in this case, a database. We want to free developers from having to be responsible for the things that security does as a part of its job, the compliance, audit requests, provisioning access, managing the security budget or being responsible for aspects of the security budget. We and equally want to empower the security team to enable these solutions, provide a platform that covers human and non-human access, because there's some continuity there. Application identities. Applications are deployed either by people directly or indirectly through automation. And so the automated processes need identities, because those are true privileged identities that have root-like access to target systems for configuration and deploying applications. And then similarly, applications need identities in order to connect to databases and other services. So we're trying to enable both sides of this equation, shift security upstream, shift it left into the development workflows so that it becomes just a natural part of the rhythm of development, not something that's tacked on later, which can be problematic. So if we go to the next slide, the problem that we see is that while developers have gotten the message that embedding passwords or hard coding secrets in source code is a really bad idea, you need a place to store those secrets if you're not going to have them embedded in your application. So where do you store those? Well, there's no lack of places to store secrets. Most of, if not all of the DevOps tools and cloud platforms have a place to store secrets, some kind of vaulting capability for storing and retrieving secrets. But these solutions in many cases are not very secure. You may have dealt with Kubernetes secrets. We'll show an example here where, as you may know, Kubernetes secrets are only base 64 encoded. So these are not what we would hold up to a standard of high security. Most of these solutions are not ready. But the point is, even if all of these things were secure, having multiple ways of storing secrets makes it hard to share best practices, established best practices, hard to provide segregation of duties, and it certainly makes governance risk compliance reporting next to impossible. So this is the problem that we're solving with, and if we go to the next slide, with a solution that spans the enterprise. So what we're providing is an enterprise spanning service that can be delivered by the IT security team that solves both human and non-human access requirements. We want applications to be able to get their secrets in a way that's natural for the applications, but is provided and sourced from the same resources that are controlled by the security team for human access, as CyberArk's been doing for 20 years. So we see this as a natural extension of what we've been doing for a long time now. We've been securing application access for well over 10 years. But with the rise of automation, and certainly with the rise of container orchestration, the challenge has become, how do you do that in these very dynamic environments? And so that's what we're going to be focused on today. While we have out-of-the-box integrations with robotic process automation solutions, security scanning solutions, the things that you see on the left, we have a number of partner companies that have built integrations that use our solution for provisioning secrets. So you think about a container scanner, or excuse me, a security scanner needs to connect to multiple different backend systems. It needs credentials to do that, and that's why we have a hefty length of customers or companies that have built integrations for doing just that. But as we get more into the DevOps space, and especially with container orchestration, we look more toward the development community, and how do we enable the development community to deliver that business value quickly, but also do it securely. And to do that, we are providing this enterprise spanning service for secrets management. So that takes us into what are we really going to be talking about today. If we go to the next slide, the solution that we are providing is, as we say, it's an extension of what we've been doing for a long time. Our vault is the system of record for secrets for many thousands of customers today. They are using the capabilities provided by our solution to control human access to resources, and in many cases are already using that to control application access to resources. Now we're talking about applications being deployed in OpenShift. And these applications, as you know, may not live very long. They come and they go, they move around, and that complicates the challenge of providing a strong authentication strategy for authenticating first these applications, controlling their access second, and then auditing their access third. So the solution that we've provided does just this in OpenShift. And what we're going to do is step through a few examples of how applications can retrieve their secrets in an OpenShift environment. If we go to the next slide, we'll look at the architecture for this. So this is the architecture for the lab examples that we're going to walk through here. So the Enterprise Password Vault is actually running on my laptop here down in Austin, Texas. It is synchronizing secrets to a primary node in the Dynamic Access Provider cluster. So the Dynamic Access Provider is a solution formerly known as Conjur Enterprise. It is a part of the CyberArk product suite. There is an open source version available called Conjur still. So conjur.org is where you would go to get the open source version. The enterprise version is called Dynamic Access Provider. That it's a multi-node architecture, and the primary node is actually running in Azure. So the synchronizer on my laptop is connecting to that master node or that primary node in Azure, and it's replicating. We're replicating the secrets that are managed in the core vault to that primary node, and then it replicates those secrets to other nodes that provide read-only access to those secrets. So this is how we start distributing secrets around a distributed architecture or an extended enterprise. You can run followers where you want access to secrets. Followers depicted by the multi-triangle diagram down at the bottom in the CyberLab namespace. The followers are actually running in OpenShift, and they are serving secrets to the applications in OpenShift. So applications can get their secrets from a local provider. They're not making long distance calls through firewalls and security groups in order to get their secrets. They're getting them from a relatively local source, and that source is kept up to date by this synchronization process that we've set up. So this is the depiction of the lab. We've got the follower running in a namespace called CyberLab, and we've also got a MySQL database there. That's going to represent the target system. This is the thing that applications want to connect to. And then we've got a user namespace, which will be user one. This is actually going to be using a lab that Vijay and I have been collaborating on for showing how to do secrets management in OpenShift. So the cluster is actually running in AWS, and we actually used the AWS deployment capabilities in OpenShift 4 to put that cluster up. So this is using version 4.3.3, so almost up to date with the latest release. So this is something that you could deploy today, and it works back compatible with the older 3.x versions of OpenShift as well. So if we go to the next slide, we're going to walk through. I'm going to tell you what you're going to see, and then I'm going to show you, and then we'll come back to that to review what we saw. The overall workflow for retrieving a secret is first you authenticate. So however authentication happens, in this case, authentication is done for us by a helper container in the pod. So the application is not responsible for authenticating itself. And we're actually using a variation of a protocol that is used in other cloud native applications like Istio, for example. The Istio service mesh uses an authentication protocol that's similar to what we're doing. Basically, what we're doing is validating the identity of a pod with the OpenShift platform. So we allow list or whitelist the application's identity in terms of metadata that can be validated with the OpenShift platform. This enables the authenticator to then receive credentials issued by the follower in the form of an X509 cert and private key to set up a mutual TLS connection with the follower, and then get an access token that it can provide for the application. So all of that authentication protocol is handled by the container. The application simply gets an access token, and it can use that access token to retrieve secrets. This access token is short-lived, so after 8 minutes, we would have to re-authenticate. And so we'll show the various ways that this happens, and then the various ways that we can relieve the developer of having to retrieve secrets for themselves. But this workflow, authentication has to happen. It's a zero trust model, default deny. If you're not authenticated, you can't do anything. If you're authenticated, then you're only allowed access per a policy that defines what the identity is allowed to access. So It's extremely secure. We typically can spend a good hour to an hour and a half on this topic, so I won't belabor it anymore now. But we'd be more than happy to set up a session with anyone that's interested to dig deeper into this this whole process and how it works. So that takes us to the labs. So we'll see some aspects of this workflow. We'll especially see the access token that's provided by the authenticator container. But if we step to the next slide, we'll describe what the demos are going to look like. So in the first lab, a lot of people just want to use an API. They don't want anything more than just tell me where I go to get my secrets. Show me your API. And most often than not, they're looking for a REST API. And so we have that, and it's documented. You can go to docs.cyberark.com. All of our documentation is online. There's no gate around it, so it's free to access. So in the first example, we're going to use a REST API to simply pull a secret. So what we'll see is it's just a simple bash script that picks up that access token that's provided by the authenticator. The authenticator is running as a sidecar, so it stays running, and it can refresh that access token on a regular basis. So we always have the ability to retrieve secrets. And that makes sense if you're using an API, because the API may need to pull secrets through the lifespan of the application running. So we'll see how we can use that access token to retrieve the MySQL database username and password and connect to the database. So that'll be the first example. I'm going to step through all of these because when we switch, I don't want to switch back and forth between Vijay's presentation and mine. We start doing the demo. So the second example is going to be an example of secrets injection. That's going to be using an open source component that we built called Summon. Summon runs in the application container, and it pulls the secrets and calls the application with those secrets in environment variables. The beauty of that is the application developer doesn't have to know how to pull secrets. The application simply accesses those secrets as environment variables, but those environment variables are dynamically instantiated by Summon using the same identity. So it's using still the same authentication strategy, using that access token to retrieve those secrets. But now the application can get its secrets without having to know how to retrieve them and connect to the database. So that'll be the second example that we look at. And in that example, the authenticator is running as an init container because it provides that access token. When the application container starts, Summon picks up that access token, retrieves the secrets, calls the application, and then the application is off and running with those environment variables. But it starts to beg the question, what happens if those values change? What happens if secrets get rotated while the application is running? So this is an aspect of password change management that often comes up, and we'll see a couple of ways to solve that. In Lab 3, oftentimes applications are already built to use Kubernetes secrets or OpenShift secrets. And while those aren't ideal from a security aspect, we've had a lot of requests, and we've delivered a solution that will dynamically instantiate Kubernetes secrets. So in this case, what happens is the authenticator running as an init container will authenticate, will actually retrieve the secrets described in a Kubernetes secrets manifest, and then patch that secret with those instantiated values. So the Kubernetes manifest does not have the base 64 encoded values for the database username and password. Those are dynamically patched, and we'll see how that works. But this is proven to be pretty popular because a lot of folks are already using Kubernetes secrets. This makes that migration very transparent and very easy while increasing security. So getting at that, sort of reducing the friction between development and security, this is a way of doing that. The last example is using a solution that we provide called Secretless. So as we'll see in all the first 3 labs, we display the username and password. And that in itself is a problem because applications can inadvertently leak secrets in logs or to standard out, or when they're doing debugging. And if that happens in production, then the application can inadvertently leak production secrets. So the best kept secret is the one that's never shared, and that's what Secretless is all about. Secretless proxies the application's connection to the database. Secretless is the thing that authenticates, that retrieves the secrets and establishes the connection to the database. The application doesn't use a username and password. It doesn't have access to the username and password. It never gets the username and password. it simply connects to the database as if it were listening on the local port. What's really listening is that broker, and it establishes that database connection using the secrets that are never shared with the application. So that's the fourth example that we'll look at. So with that, Vijay, if you'll make me presenter, I'll start walking through these scenarios, and we'll come back to review these just so that everybody if they have any questions about what we're talking about, then we can certainly show that.
Yep, absolutely, Jody. Give me one moment, please.
All right. All right, Vijay, are you seeing my bash shell at this point?
Yes, I can see that.
Excellent. All right. So the first example, so just to give a kind of a overview, here is our cluster. It's running up in AWS. You can see that the provider is AWS. We've got 4 nodes, 2 are admin nodes, 2 are worker nodes. We've got a namespace. We go to our projects here. We've got a namespace called CyberLab. Which is running our follower. And if we look at the workloads here in the pods, we've got a follower and the MySQL database. We can get the fancy rendering of that if we switch to developer, and we see those 2 pods running in that project. So the SQL database is really what we're wanting to connect to. The follower is going to be providing the credentials to connect to that database. And we're going to see that in those 4 scenarios that I walked through. So that first one, where the authenticator container is running in the sidecar. So if I do an OC get pods, we see that we've got my 4 examples running here. So I'm going to look at this example first. We can see that there's 2 containers, 2 ready. So that's the application container and the authenticator container. If I exec into that, I'm just going to use my utility here to avoid typing. I'm going to exec into this container and cat out this script, which is that bash script that I talked about, that use the REST API to retrieve the secret. So these are the names of the secrets that I'm going to retrieve. The first thing I do is I pick up that access token that's provided by the authenticator container. So I don't have to know how to authenticate. All I need to do is know where the authenticator put that token. It's in a shared memory volume. So I pick that token up, base64 encode it, trim the whites, the control characters, Perl encode the names of the variables that I'm going to retrieve. So these slashes become %2f. And then I make my REST calls using curl and using that token as a bearer token to retrieve the username and the password. Then I display those, which is basically leaking the secret, but just showing that we've got that. And then I make my MySQL client call using the username and password, and it'll complain that putting those in the command line is insecure, but this is the demo, so we're not as worried about that. So here we see I echoed the values of those secrets. So these secrets were retrieved from the follower using the REST API. And now we're connected to the MySQL database. And I can do things like show databases. And now if I am the application, I can do whatever this account is allowed to do in that database. So that's the first example. As we said, that the sidecar deployment refreshes that access token so that the application can always retrieve its secrets. So if you're using an API, you don't have to retrieve all your secrets up front. You can retrieve them as the application is running and use that access token and know that access token is always going to be fresh as long as you keep picking it up. And that's critical, because if you keep that access token and that 8-minute window expires, that access token won't be good anymore. So you need to keep getting that access token from the file. So that's a sidecar example. So let's look at a init container example. This is going to be using summon to retrieve secrets. And as we said, summon is running in the application container. So this has to be built as part of the application. So if I say summon here, it's going to say, tell me what I need to run. So what I'm going to run here is a much simpler MySQL application called MySQL summon. In this, we see all it's going to do is echo the values of the environment variables, and then, as before, use those environment variables to connect to the database. Now, if I run this without running summon first, then not much is going to happen because those environment variables aren't populated. The way someone knows what to populate is through a file called secrets.yaml. So this is a helper file that describes the names of the secrets to retrieve and the names of the environment variables to put their values in. So this someone will iterate over this file, retrieve a secret with this name. Same thing we saw in the REST application. So we're always going to be pulling the same secrets, the username and password for the MySQL database. In this case, now someone's going to pull those secrets and call the application with those secrets and environment variables. So I say summon. Now I say MySQL summon. Now those environment variables are populated. Well, guess what? My token expired. I deployed this application before the webinar started. And so this is an example that where the access token has now expired. So what I would need to do is redeploy that. Let me do that real quick. So I'm redeploying the application, which will restart the init container, which authenticates, provides that access token, and then we'll have a fresh access token that we can actually use in the application. So that's a real-time example of the difference between that sidecar deployment and the init container deployment. So it's still initializing. This is exactly why I had everything deployed earlier. So, so now we're going to run this, and now we should have an access token that is more friendly to us. Well, let me move on to the secrets provider. We may come back to that, but what I want to show, so as I said, the third example is using Kubernetes secrets and dynamically instantiating Kubernetes secrets, which is something that customers seem to like because their applications are already using Kubernetes secrets. They realize there are some trade-offs with Kubernetes secrets. We're always quick to point out that caveat that Kubernetes secrets, especially mounted as environment variables, may be visible to certain tools outside of the container. So if you were going to use Kubernetes secrets, we always recommend mounting them as volumes, not as environment variables, because there are other tools out there that can show you the environment variables for a given pod. But once they're secrets, you can do whatever you want to them because now they're just native Kubernetes secrets. It's just that we're dynamically patching them. So the way this works is we look at the secret manifest here. So the problem with one of the problems with Kubernetes secrets, so I talked about the runtime fact that they can be exposed as environment variables. The other thing is if you have a manifest, the manifest is going to have those secret values base64 encoded. So if I have these values here and I cat this value or echo this value here and pipe it to base64 decode, then I get the name of my database. So if this gets checked into my GitHub repo, then it's very easy for someone to go through and find those secrets and decode those and potentially get your username and password. So what we've done here is we said, okay, here's a map. Here's an array of values, keys and values. The value here now isn't the value of the secret. The value is the name of the secret at the follower. The same values that we've been using in the other examples. And now what the provider is going to do is pull those secrets and patch this secret at runtime to base64 encode those values as if they've been part of the manifest. But the manifest never has the username and password in it. It's only got the names of those secrets. And so that's what the provider does. If we look at the logs, for example, so the provider runs as an init container, it authenticates, and actually let me get my pod. So what I want to do is look at the logs real quick of the secrets provider. So this is I've got it in debug mode, so just we show the work here. So we log in and we're authenticating as this identity. We get logged in, we get our cert. This is our authentication credentials issued by the follower after it successfully validated the identity. We successfully authenticated. Now we're retrieving the DB credentials in the namespace. We're processing that conjure map, retrieving these secrets, and then updating DB credentials in the namespace. So if we look at the secret here, we do an OC describe secret DB credentials. Now we see we've got username and password are both 8 bytes. These are, that's smaller than what it was before. If we do an edit, we can actually see those values. And we can see at least that they are now instantiated. So here we see the password is instantiated. So we've dynamically patched the secret to contain a base64 encrypted password. If I echo that value and pipe it to my base64 decode, then I get my password back. But that wasn't part of the credential that would be stored in your this one. So we can see that those didn't exist. Those only exist in the runtime example. So they don't get checked into GitHub. They don't get stolen, and life is good. So if we exec into the container now, we can see where these are provided. And I've mounted them both as environment variables and in the volume, just so that to show that example. So if I do an env and grep for things beginning with db underbar, then we can see there's my test app username and password mounted from the Kubernetes secret. So it's just a native Kubernetes secret at that point, but has been dynamically patched so that those secrets are only there for the lifetime of this application. I can also retrieve those secrets as we recommend as volume mounts. So here's the password, and the password's there too. So that's what I will be using here when I do the provider. It will use the value retrieved from the file to connect to my database. So now I've connected to the database with the secrets provided as Kubernetes secrets. But realize in every one of these examples, I am echoing the username and password. The application has direct access to the username and password so that it can connect to the database. But what the application really wants is the connection to the database, and the credentials are just a means of controlling access to that. So what if the application didn't have to retrieve secrets at all? And that's the idea behind secretless. It's using a proxy connection, which is what we use to control human access to privileged systems. So in the user space, when a human needs root access to a target system, the CyberArk privileged session manager will have the user log in as themselves to CyberArk. And if they are authorized to access that target system, the privileged session manager will establish a root session using the root password on that system and monitor that access. So the user never gets the root password. And that's why we say the best kept secret is the one that's never shared. So what I'm going to do, we look at the MySQL secretless example here. Oh, we got to exec into the container. And I've got a log down here on the secretless broker. So this is the proxy container. So it's running as a sidecar in the same pod with the application. The application, in order to connect to the database, is just going to try and connect to the database as if it's listening on the local port 3306, the default port for MySQL. So there's no username, there's no password, there's no URL. Nothing could be simpler here, right? And the application's not going to get access to the secret. So what we'll see, we see that the listener is listening on the local port. So basically the secretless broker is listening. And so when the application goes to connect, the broker is going to authenticate, retrieve secrets, and connect the application to the database. So I didn't need the username and password. I don't get the username and password, but I still get my connection, which is what I wanted in the first place. So this is building on that sort of rich tradition of proxied connections that has proven very, very successful in the user space, and now we're applying it to applications. And this works for MySQL, works for SQL Server, Postgres, HTTP and HTTPS connections, and SSH connections. It's a multi-protocol broker for providing access without divulging the secrets that provide that access. So that's the demo. So why don't we flip back? Let me make you presenter again, BJ. Let's kind of summarize what we did here, and then answer any questions.
Oops.
There it comes.
Okay.
So just to review, we saw 4 different ways of retrieving secrets. First with the REST API, using that access token provided by the authenticator, and that access token is kept fresh because the access token, the authenticator is running as a sidecar. Second example, which we didn't quite get through, is where someone would retrieve those secrets and then call the application with those secrets in environment variables. Third example is where we dynamically patch the Kubernetes secrets to provide the more native Kubernetes or OpenShift experience. It works equally well in Kubernetes or OpenShift. And that way, applications can use Kubernetes secrets like they're used to, but the Kubernetes secrets don't get checked into GitHub. And then in the last example, we use the secretless broker to broker the connection to the database without the application ever getting the username and password, which we saw was very easy for the application to leak in the other examples. So that gives you a sense of what we're trying to do, especially in the OpenShift space. The things that I really like and appreciate about OpenShift is its strong role-based access control, where we can grant exactly the privileges needed to do these operations and no more. And so our deployment models and our labs really leverage that fact, where this multi-user lab that I was walking through here, each user is only able to deploy in their environment, while other applications can be deployed in other environments. So we can partition responsibilities very closely. We can assign identities to applications based on OpenShift service accounts and the namespace that they're running in, and scoped by the cluster that they're running in. So you saw Vijay mention the multi-cluster management that Red Hat's rolling out. Being able to establish an identity, a good example is you want your dev cluster to mirror your prod cluster, but you don't want your dev identities to have access to your prod resources. So having identities scoped by the cluster is very important. You want the dev identities, you want your namespaces and service accounts to be the same, but you don't want an identity that's in dev to be able to access production secrets. And being able to define identities using the cluster ID, the namespace ID, and a service account gives you that sort of specificity around identity definition that's required for good segregation of duties. So why don't we switch to question and answer? I think we're starting to run short of time.
Yeah, we do have a couple minutes for questions. If you do have a question, please go ahead and use your GoToWebinar control panel and submit it. We're probably not going to be able to get to everybody's questions today, but please know that the folks at Red Hat and CyberArk will be getting a copy of all the questions. So even if we don't get to it during the webinar, they will be able to answer it offline post-webinar. Let's go ahead and go into the first question here. Let's see. CyberArk mentioned, I think, 4 different ways for how applications can fetch secrets, including REST API and environmental variables. What would you recommend I use for OpenShift applications?
I'll take that one. And I would say if secretless works for you, I would go there first, because that is going to be the most secure. It's very much in line with service mesh type architectures, so it's very forward looking, and we're investing pretty heavily in it. But if for some reason, so for example, it doesn't yet support Oracle database. So if you need connections to something that secretless doesn't support, then you can kind of pick your poison, as they say. A lot of people seem to like the fact that we can dynamically patch Kubernetes secrets and use those and kind of get around some of the security concerns that Kubernetes secrets introduces. So I would probably recommend one of those 2 approaches first. But everybody's different. Some people really just want to use an API. And so we've got the REST API, plus we've got .NET, Ruby, Go, and Java client libraries that wrap the API and give a higher level interface to those capabilities.
All right, great. We're about 5 minutes to the top of the hour. If we could do one very, very quick question next, and then we'll close out question and answer period. Here it is. What is the release cadence for OpenShift 4.x?
Yeah, that's a great question, Charlene. So currently the cadence is about 3 to 3.5 months, and that's been the case with all of the OpenShift minor releases with 4 so far. So we came out with 4.1 right after the summit last year, and then it's been progressing. 4.5 is slated, I believe, for release sometime in July or early August. And that 3 to 3.5 month cadence would be there because there's a furious pace of activity and features being positioned for OpenShift based on what we see with our customers and partners. And those are getting baked into the product and tested as quickly as possible. So the cadence is about 3 to 3.5 months.
Okay. All right, great. As I said, if we didn't get to your question, I apologize, but the folks at Red Hat and CyberArk will be getting a copy of all the questions. So I'm sure they'll be more than happy to follow up with you offline to get your question answered. I do want to thank everybody who did submit questions, though we did have a lot of them, and sorry, we just ran short on time. Do want to remind the audience also that today's event has been recorded. So if you missed any or all of the event, or if you just want to watch it again, you'll be able to do so. You will be getting an email following today's webinar that contains a link to access the webinar on demand. And the webinar is also going to be living on the devops.com website. So you can always go look for it there. Just go to devops.com/webinars, look in the on-demand section, and it should be right there waiting for you. Okay, at the top of the webinar, I did mention that we would be doing a drawing for 6 $25 Amazon gift cards. So let's go ahead and do that right now. Let's see, our first winner today is Alex D. Congratulations, Alex. Our next winner is David L. Congratulations, David. Our third winner is Felipe N. Congratulations, Felipe. Our fourth winner is Joan S. Congratulations, Joan. Next winner is Scott F. Congratulations, Scott. And our final winner today is Tony M. Congratulations, Tony. Congratulations to all of you. We will be following up with you via email to get your $25 Amazon gift card over to you. So please check your inbox for that. All right, well, BJ and Jody, thank you so much for a great presentation today. Lots and lots of really great information, and judging from the number of questions we got from the audience, I know they got a lot out of it also. So thank you very much for your time and your expertise. Really appreciate it.
Thank you, Charlie. Thanks everybody.
Great. Also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I am signing off. You have a great day, everybody. Please stay safe.